y equals 3x minus 2. What's the slope? The slope is a number in front of the x. When you look at the graph, starting from the y-intercept of negative 2, for every 1 unit you go to the right, you go up 1, 2, 3 units. As for the y-intercept, we can see that this number here, minus 2, means that the line crosses the x-axis at negative 2. When the y-intercept is negative 2, it means that the x value is 0. 0, comma, negative 2 are the coordinates of the point of intersection. Now, how do we find the x-intercept? The x-intercept is where the line crosses the x-axis. It's around here. We have the line equation y equals 3x minus 2. We set the y value equals to be 0. So 0 equals 3x minus 2, and the rest is algebra. We just throw negative 2 to the left, and we divide both sides by 3. Thus, x equals 2/3, or approximately 0.667. Now let's create a table of values for this function. When x equals 0, we plug it in here. Y equals 3 times 0, which is nothing, minus 2, so the final result is minus 2. Now substitute 1 into here. 3 times 1 is 3, minus 2 is 1. We continue substituting the numbers 2 and 3, and we can see that these numbers, the y values, go up by 3's. So negative 2 plus 3 is 1, 1 plus 3 is 4, 4 plus 3 is 7. When x equals 100, let's find the y value. We substitute x equals 100 into here. So y equals 3 times 100, which is 300, minus 2 is 298. Now when y equals 10, let's find x. We substitute 10 into the y value here, and the rest is algebra. We add 2 to both sides. We get 12 equals 3x, and then we divide both sides by 3, so x is equals to 4. Now, is the point 7, 15 on this line? Using Desmos, we see that clearly it's not. Algebraically, we substitute 7, x equals 7, into the line equation. When x equals 7, y equals 3x minus 2. 3 times 7 is 21, minus 2 is 19. We're expecting a y value 15, and we get 19. Thus, 7, 15 is not on this line. Now, what about the point negative 5, negative 17 over here? Visually, we see that indeed it is on the line. Algebraically, when x equals negative 5, again, substitute into the line equation here. 3 times negative 5 is negative 15, minus 2 is negative 17, which is the same as the y value here. So we calculate the y value algebraically to be negative 17, which happens to be the same as the y value of this point. So indeed, this point is on the line.